Hello everyone, I am Ayush and in this video we are going to understand about an important concept of mathematics, that is arithmetic progression. So arithmetic progression is a part of progression. So what does this term progression means? Progression. The term progression means it is a sequence of numbers. There are lots of numbers in this progression, but they all follow a fixed or a definite pattern. So let's take an example, a sequence of natural numbers. It starts from 1, 2, 3, 4 and so on. So this is a sequence of natural numbers, but here we can see a fixed pattern. Each number, the difference between two consecutive number is 1. Here we can say the difference is 1. So this sequence of number follows a definite or fixed pattern. So this is known as progression. We can take another example like 2, 4, 8, 16. So in this case, each number is square of the previous term. This number also follows a fixed pattern. So we can say progression is a sequence of numbers in which each number or that follows a definite pattern, and as well as we can represent the term of this progression by any general formula. Okay, so there are three different types of progressions. First one is arithmetic progression. Arithmetic progression. Second one is geometric progression, which can be represented by GP. And the third one is harmonic progression, which is HP. So in this lecture, we are going to study about arithmetic progression. So in case of arithmetic progression, it is a sequence of number, but the difference between two consecutive number is always a constant value. Means that we have a sequence of numbers like 5, 10, 15, 20 and so on. So in this case, the difference between two consecutive, here the two consecutive number 5 and 10, the difference between 10 minus 5 is 5. Again the two consecutive number 10 and 15, and the difference is 5. 15 and 20 consecutive difference is 5. So we can say that this is an arithmetic progression. Let's take another example. Suppose we have a sequence of numbers like a plus b, a plus 2b and so on. So here we can say that, see that the difference between two numbers a plus b minus a is equal to b. Again a plus the two consecutive number is a plus b and a plus 2b, and the difference is a plus 2b minus a plus b, it is a b. Or we can say if we add b to the first term, then we will get the second term or the next term. Next term can be obtained by adding a constant value to the previous term in each conditions. Then we can say that this is an AP, but this is not an AP. Why? Because here we can say 4 is an square of 2. Okay, or we can see we can obtain 4 by multiplying by 2. 4 multiplying by 2, 8 multiplying by 2. It follows a definite pattern, but we do not have to add a constant value. Rather, we have to multiply it by a 2. So this is not an AP. For AP, we have to obtain the next term by adding a constant value to the previous term. Now, in case of arithmetic progression, there are some three things are always present. First one is first term. And the first term of AP can be represented by A. Again, now this constant value in case of AP each sequence that consecutive terms is differ by a fixed number, and that fixed number or constant value is represented by common difference, which is known as common difference. Or we can say this is a common difference between two consecutive number of an AP, and it is represented by small d. And this arithmetic progression, we already know that the nth term of a progression can be represented by a general formula. So the general formula for AP is a plus n minus 1 into d. Or we can say that a plus n minus 1 into d. Now Arithmetic progressions are classified or divided into two types. First one is finite arithmetic progression and second one is infinite arithmetic progression. First one is finite arithmetic progression and the second one is infinite arithmetic progression. So, infinite AP. In case of finite arithmetic progression, we can say that this AP has an end. We have started an AP and after some terms it came to an end. Then it is known as finite AP, or we can say an AP which has a finite number of terms is known as finite arithmetic progression. And the next one is infinite AP, means an AP which has infinite number of terms. We cannot find the last term of an infinite AP because it does not have any end. So, in case of finite AP, we can find the last term, and the last term of finite AP can be represented by term L. So, last term of an AP can be represented by the term L. So, it shows that the number of terms in AP is finite. Now, how can we calculate the nth term of an AP? So, first, let's suppose we have an AP 2, 4, 6, 8, dot dot dot, and this is an infinite AP. So we do not have the last term. So then we have to find the 50th term. How can we find the 50th term of this AP? So now we can see that the first term of AP is 2, second term of the AP is 4, third term is 6, 8, and so on. So how can we calculate the 50th term? First we have to determine whether it is an AP or not. Here we can see that the difference between the two consecutive terms is 2, again difference is 2, and again difference is 2. So we can conclude that this is an AP. Now we can apply the formula to find the nth term. So here we can write a first term is equal to 2, and the common difference between two consecutive terms is 4 minus 2 is equal to 2, and nth term, so n is equal to 50. We have to find the 50th term. Now by applying the general formula, nth term for Tn, or we can say An, is equal to a plus n minus 1 into d. For 50th term, n is equal to 50. First term is 2 plus 50 minus 1 into d. So 2 plus, here d is 2. So 2 plus 49 multiplied by 2. 2 plus 98, that is 100. So here we can conclude that the 50th term of this AP is 100. And we can easily find the nth term of any AP by using this formula. So we can say that in case of arithmetic terms, the nth term can be represented by a general formula, that is An is equal to a plus n minus 1 into d.